Okay, YouTube, in my last video we talked about how to graph quadratic inequalities in two variables. In this video we're really going to focus on solving quadratic inequalities in one variable, which essentially, we'll just go ahead and visit here. We say a quadratic inequality in one variable. It can be written in one of the following forms where a, b, and c are real numbers and we don't allow a to be nothing. But essentially you can see here that in the last video we had like ax squared plus bx plus c was greater than or less than or greater than or equal to or less than or equal to the y value. In this video we're going to say specifically what we've got this set equal to is 0. And I want to say equal to 0, I want to say unequal to 0, either one side or the other. So in this particular case we can solve these inequalities using algebraic methods, or we could use graphs. So the next video will be about graphs. In this one I'm just going to walk you through how we solve these algebraically. So let's go ahead and start by considering this quadratic inequality in one variable. I notice that it's got a 0 on the right side here and we're only in the variable x. So we say x squared plus 4x minus 32 is greater than 0. I want to know, when is this expression positive, essentially? And so what we're going to do first is this. We're always going to replace this right here with an equal sign, and then what we're going to do is we're going to solve for the zeros of the function, and we're going to refer to these as being our critical values of the inequality. So in this particular case, we have x squared plus 4x minus 32 is equal to 0. So what we're going to do is we're going to solve this by factoring. I would notice it would be really convenient to solve this by factoring. We would get this. Let's see, 4 times 8, I suppose, would be 32. So 4 times 8. We could do a positive 8 and a negative 4. And those would add up to our 4 in the middle. So knowing that these are our factors, what we'll do is we'll just go ahead and set those factors equal to 0. And we'll solve this by factoring. So what we end up with here is this. We get x equals negative 8. We also get x equals 4. So these right here, we're going to put a box around these. And we typically call these the solutions, or the zeros of this function. But in this particular case, we're going to refer to these as our critical values. Okay, so these critical values are important to us when we're solving a quadratic inequality in one variable, because what we're going to do next is we're going to graph those zeros on a number line. So what we're going to do is this. I'm going to go ahead and make my number line here, and I notice that I'm going to have to go left 8 and right 4. So here's what we'll do. We'll say 1, 2, 3, 4, 5. We'll call this 5. And then 1, 2, 3, 4, negative 5. 1, 2, 3, 4, negative 10, and negative 5. So you'll notice that I say here, use an open dot for both, since our initial inequality is greater than and not greater than or equal to. So in this case, what I want you to know is, in the last video we said use a dashed graph for a greater than or less than, and a solid graph for greater than or equal to or less than or equal to. We're going to do kind of a similar thing here, but we're going to put an open dot on each of our critical values here. So I know I have one at negative 8 was an open dot, and at positive 4 we have an open dot. So what we're going to do is we're going to say that these numbers really, they split our number line up into what we call test intervals. So what I mean by interval is this. We could say that the whole number line you can think of as being split at these values, and each of these test intervals either have the solutions to this inequality or they don't. And so in order to find out whether or not they have a solution to it, what we're going to do is we're going to choose an x value that lies within each of these subsections, from way out at negative infinity up to negative 8, from negative 8 to 4, and then from 4 to infinity. We're going to choose a convenient x value to plug in and say, does it make it true? Because this representative x value, if it's true, it will tell us that every other x value in that interval of values will also have to be true. So you notice I say, if it gives a true statement, then shade the corresponding interval. If not, then we're not going to shade that interval. So the very first x value I'm going to choose here is not negative 8 itself, but one to the left of that. I'm going to choose negative 9. And I'm just going to say, is this a solution to the initial inequality? So what we're going to need to do here is we're just going to need to plug this into our inequality. And so we would get this statement here is greater than 32. We're going to plug in our negative 9. Negative 9 and negative 9. So here I get 81. This would be minus 36 minus 32 is greater than 0. 81 minus 36. Let's go ahead and check this out here. So we have 81 minus 36 minus 32. And what we find out is that we get a positive 13. So this positive 13 on the left here tells us that we get a true statement here. This is true. And so since this is true, we should shade the 9. But if 9 is true, then everything on this interval to the left of negative 8 is also true. We're basically going to shade to the left, and I'm going to draw an arrow on the left side, and just to indicate that these are all solutions to this initial inequality. So now going into this middle interval, I'm going to test 0 because it is a nice interval value to test here, not interval value, but a x value to test, and we get, okay, so blank squared plus 4 times blank minus 32 is greater than 0. We'll test this in the initial inequality. So I get 0 and 0, which gives us 0 plus 0 minus 32 is greater than 0, which negative 32 is not greater than 0. So what this means is I'm not going to shade 0, but it also tells me that everything in this middle interval is also not going to make this initial inequality true. And then last but not least, I'm going to choose to select 5 and plug that into the initial inequality. And so we get 5 squared plus 4 times 5 minus 32 is greater than 0. So we get 25 plus 20 minus 32 is greater than 0, which 25 plus 20 is going to give us 45 minus 32. And I can already see that this comes out to be positive in this case. And so since it does, I would say that 5 would make this true, but everything to the right of 4, it also follows, must also make this true. So in other words, when we solve these things, we're going to solve for the zeros and put those on the number line, and then we're just going to test interval values in each interval and see if it makes it true or not, and shade it if it does and don't shade it if it doesn't. So our last step is basically going to be this. We're going to need to write our solutions as a set of inequalities. We say, what are all the x values that cause this to be true? Well, we notice that all x values less than negative 8 made this true. So we say x less than negative 8 made this true. But also, we could just, I guess, write and. X greater than 4 would also make this true. So the last thing I want to mention in this video before we tune out is this. The only thing that's going to change about everything that we did here, if we had, say, a greater than or equal to or a less than or equal to, is this. We would not have put open dots here. We would have put closed dots. And when we wrote our solutions down here, we would have included an or equal to had it been an or equal to relationship in the first place. Cheers.